Okay, in the last video that I made, I was looking at injection duration and I mentioned fuel rail pressure, so I thought it made sense to jump towards the end of the file and look at the rail pressure maps. So here we've got 1, 2, 3, 4. Is that 4? Yep, so we've got 4 rail pressure maps. They all look very, very similar, so I don't think there's a huge difference in them. If you look at the shapes of those, they all look very, very similar. It's not surprising. Sometimes there will only be one because there's just one map and that's it, or sometimes there's multiples but the difference between them is not very much, or sometimes you might get perhaps just 2 sets of maps and one is for normal running and one is for regeneration, that sort of thing. But basically that's what they're there for. They're determining the amount of pressure that's going to be in the fuel rail. Now if we open one of these up, usually fairly easy to spot because of the massively high numbers. Now the maximum that you will see in most of these is somewhere in the region of this value here, so the 1800 value. So you will see a value of somewhere around about 1800 excuse me, and then you will usually have a factor of 100, which obviously adds another couple of noughts on the end. So usually the maximum is somewhere around about 1800. Some peak at about 1600, but these are still values that are way above the values that you see on most other maps. So it's a fairly good clue to the fact that you're looking at a map to do with rail pressure. Winnows often finds these maps anyway, so that obviously helps. And then of course you've got the characteristic shape. They're a reasonably obvious shape. If you've been used to looking at pump juice engines, in other words PD engines, then these are never found because you don't have a fuel pressure rail. So in EDC17 you don't get these if you've been looking at PD engines, but of course if you've been looking at non-PD engines, in other words injection systems with a fuel rail, then you will have been used to seeing shapes like this for the fuel pressure. Right, now the way they work is fairly obvious, just like the duration map was fairly obvious. At the side we've got engine speed, revs per minute, usual factor 0.5. Along the top we've got the amount of fuel, still in milligrams per cycle though, so not in millimeters cubed, so not as a volume, still in milligrams per cycle. And we are finding out how much pressure we will have in the rail for a given value, and it's fairly obvious, isn't it? I mean, what would you expect? At low values in terms of injection demand and at low values for engine speed, you would think, well, I don't need a lot of pressure, so the pressure can stay low. It doesn't have to stay low, it could be high, but I don't need it to be high. So the values on the map can be low because I don't need high values. And then as we go up through the rev range and through the amount of fuel we want to inject, in order for duration to work well, I'm going to need a higher pressure. So I can expect basically to find low revs with low injection quantities. I've got reasonably low pressure, and at high revs and high injection properties I've got high pressure. The map could be set at this 18000000 value all over, but it would be a waste because it would mean that the pump was having to work much harder than it needed to at other times. So at light throttle, just cruising, lower revs, the pump would still be putting out its absolute maximum when there wasn't any need for it. So this map allows the pump to work as hard as necessary rather than just work flat out all the time. And we've got, as you can see, a sort of emergency cutout, because if we look at this value in the last row here, at 5,500 revs per minute, the value that we've got is more or less the same as the minimum here. So we've got a sort of emergency cutout. Once we hit that point, the valve that controls the amount of pressure is just going to say no, that's it, and it's going to reduce the pressure, relieve the pressure, and now the engine will not be able to carry on revving any higher, producing any more power. So we've got a sort of emergency cut-off point at that point. So it's a very handy thing to protect the pump basically, but obviously it's going to protect the engine as well at the same time. So it's a very handy thing to have in there. People often change this map when they tune an engine. They often make the changes without really thinking as to whether they need to make the changes or not. If you've made quite dramatic changes in other maps, then you might want to make some changes to this map, but quite often you do not need to make huge changes to this map. It really depends on what changes you've made to the other maps and how and where you are demanding extra power. So you don't automatically have to make huge changes to this map whenever you want to make a tune. In fact, it is quite possible to make a tune and not touch this map at all and then see how it drives. And if you feel that it may be perhaps a little bit running out of steam, as it were, because you don't feel like you're getting the fuel through that you wanted, then you could change the map. So you don't have to make changes up front, although most people would sit down and try to work out what to do to change the map rather than make a few changes, put it in the car, bring it out, change it again. So obviously most people want to just get the whole job done in one go, in which case they might well make some changes to this map up front. Right, having identified that one, then I'll stop there.